Hey, everybody. Thank you for joining us on a brand new episode of the Clear Descent podcast. This is going to be a deep dive on frame analysis using some Wireshark and some capture tools. And I'm joined here today with Francois. How are you doing, Francois?
Very good. How are you, Roel?
I'm doing well. Thank you for joining me today, this morning. I'm looking forward to this episode. But before we get into the meat of it, I do want to thank our sponsor, Meter, for sponsoring this episode. Meter delivers a complete network stack from wired to wireless and cellular, all in an integrated cloud managed solution built for performance and scale. Head over to meter.com/cleardescend to book a demo. So today we're going to go dive into some of the frame analysis. I think this is a good topic for those who are trying to understand Wi-Fi a little bit more and also trying to get into their CWAP studies as well. We've had our fair share of packet captures and analysis, so we'll be sharing some of the stuff that we've captured, and I'll be sharing some of the captures that I've had for studying CWAP as well.
Mm-hmm. And this can be useful as well if you're troubleshooting, right? If you go in the field and you have a problem, you don't really know why it's still happening, then you can do packet capture and you can try to analyze the frame exchange and try to see if you can find the root cause of your problem. Before we talk about analysis, should we talk about how we actually capture the frames?
Yeah, I think that would be useful for those who are trying to get their captures. You want to understand what is the best way to capture some frames.
Yes, because if you just open Wireshark and you double click on your Wi-Fi NIC, you're actually not going to capture 802.11 frames. You're just going to capture what your Wi-Fi NIC is, decoding for you, which at this point will not be 802.11 anymore. It would be like the layer 3 and above. So if you actually want to capture Wi-Fi frames, the 802.11 frames, you need to have some sort of Wi-Fi NICs in monitor mode that will allow you to just sit on the channel and capture all of the frame exchange on that channel. So, you can get multiple tools out there that will allow you to do this. If you don't have any tools and you have a Mac OS, you can use the AirTool software, which will allow you to put your card into monitor mode and do a packet capture on one channel. So at least you can get some frame packets. On Windows, it's a lot more complicated. You can find stuff online. I know we've talked about it in the past to kind of make it work with some NICs, but it's a little bit more complicated. The easiest is if you have a Unix-based system, because they have a lot more monitor mode drivers, monitor mode friendly drivers for Wi-Fi NICs. And that's pretty much what's used by our tools, Me, I like to use a Sidekick from Ekahau because you have 4 Wi-Fi NICs, and that's pretty much, they use Unix.
You can capture on multiple channels with the Sidekick, which is really neat.
Yeah, you can. Yeah, they have 4 Wi-Fi NICs in the second version and 2 in the first one, so you can capture simultaneously on 2 or 4 channels at the same time, which in the field can be very very useful if you try to analyze things like roaming, for instance, and you need to capture on multiple channels. Yeah. So this is very useful.
If you're on the go, I like using this guy, the WLAN Go, WLAN Pi Go. I just attach it to my phone. It sits on the back like this, and I can do some captures, pick the channel, and it's very lightweight, fits in my pocket. I don't have to carry that many tools. So in comparison to the Sidekick 2, it's much smaller.
Yeah, the WLAN Pi Go also does Wi-Fi 7 frame captures. So if you need to study this Wi-Fi 7, you can use that as well. And it only has one card, so you only be able to do one channel at a time. So depending on what you want to do, you may want to use different tools to capture on multiple channels. We also have other tools, WLAN Pi and so on, to do the packet capture. So a lot of different options. The main thing you need to keep in mind when you do your packet capture is you need to understand which channels you want to capture on.
Yeah.
Because you kind of have to be listening on the right channel or looking at the right channel if you want to be able to analyze the frames. So you have to sometimes be a little bit proactive about what you think your client will do, or where you think your client will connect. Is it going to be 2.4? Is it going to be 5 gigahertz? Is it going to be the both? Is it going to be 6 gigahertz? And then you need to, in your environment, figure out which AP will my client connect to. Which channels are these AP operating on? And maybe you can do some testing with your client first, try to see what happens. And then you can lock yourself on these channels and capture on these channels.
Yeah, and I also like to collect these frames closer to where the client is rather than doing it farther from the client. That way you can capture as many of these frames as you want. Unless you're troubleshooting something more closely to the AP, then you want to be closer towards the AP. So you want to capture where your intended troubleshooting is going to be at, usually going to be at the client level or near the client.
And talking about the AP role, I was going to say you can also do packet captures from the APs nowadays. And sometimes it's more convenient. Some system, they allow you to track a MAC address, so you can tell the system, can you capture all of the frames related to that specific client, and you input the MAC address, and then you can get, across all of your APs, all of your channels, you can get these frames. So that could be useful.
That might be your only option, especially if you can't go on site, right? It could be your fastest option. You use an AP to perform the captures. You can capture from the over the air, but then also capture on the wired port of the AP, so that way you can capture the whole transmission and communications, and have really good troubleshooting from there as well.
So once you've captured some frames, some Wi-Fi frames, 802.11, then you can import them into Wireshark, and then you can start your analysis. First thing you'll notice is that you may have a lot of frames, right? You may have, hundreds of thousands of frames, sometimes millions of frames. And so, when you start your analysis, you want the help of the software of Wireshark to help you filter through all of these frames. And so you can use different filters. Wireshark has a very specific syntax for the filters that they use. Usually for the Wi-Fi filters, it starts with WLAN dot, and then it helps you to kind of build those filters out. But what you can even do to help yourself out even more is you can create a profile in Wireshark in which you store all of your Wi-Fi filters. And you don't have to reinvent the wheel. Some filters, some profiles already exist out there. We'll probably put some links in the show notes, in the description of the video, so you guys can take a look at them. And in these profiles, you're going to have all of your kind of default Wi-Fi filters. So if you want to filter things like management frames or data frames, then you can kind of use those predefined filters and button to get you there faster. And so, I think this is something that's very useful in Wireshark. And for the profile can also become very personal. So, what I would encourage you to do is just start from an existing Wi-Fi profile, and then play with it. Change the filters, adjust the filters, create the one that you like better. And then as you cycle through the different frames, maybe we'll share it with you in a bit. But you can also, change the columns that you're looking at. You can apply different properties as column.
Let's show what it looks like when you don't have a filter, right? So it looks.
Yes.
These are just only a few frames, but if you're looking at a lot of frames, it can be overwhelming very quickly, because it's very hard to identify anything when you've got, just a bunch of text and numbers everywhere, MAC addresses. And so these are just some of the columns I have set up. Usually I try to keep it simple at first, and then I add to it depending on what I'm trying to look for. You can right click on a column and be able to adjust what you want. So you can add specific columns if you'd like. But what Francois was talking about when it, and by the way, if you guys are listening, we do have this on the video format, which is what we're showing right now. We're showing a Wireshark, and we're looking at just a frame capture. And for the profile that Francois mentioned about, I have something down here. It's kind of hard to see, but it says profile default. But I do have the WLAN Pros master and the MetaGeek profile. But if I click on one, now you can see how some of the different frame types have different colors. So it's a lot easier to identify what you're looking at.
Yeah, before looking at this, you can also see that you have the what they call the packet diagram, which is like a view that they added to Wireshark. You see it on the bottom right of your screen, Roald, the packet diagram. This, I wish I had this when I was studying networking, because what it does is that it gives you, like the diagram of what the header fields are, bits per bit, and you can click on them and it's going to reference them into your frame. So if you click on the source address of your, of your Wi-Fi frame, or in your case here, you'll have like the receive address. You click on the receive address in the little diagram, and then it shows it to you in the frame decode section of Wireshark. So you can, if you're studying Wi-Fi, this is a great tool, because you can enable it in your preferences, in Wireshark preferences, in the layout view. You can enable the packet diagram, and that kind of shows you, based on the frame you have selected, it tells you, the different fields. So here we can see the radio tab header, which is the layer 1 information that the Wi-Fi NIC is giving us. And then you have the 802.11 header below it that gives you the information about the Wi-Fi frame. I think the one you have is an acknowledgement frame. So I guess it's a very simple frame.
Yeah, there's not much there.
Yeah, if you select another frame, the diagram will adjust itself. And this works for any protocol, not just Wi-Fi. So even if you're learning networking and you want to learn about DHCP or DNS, whatnot, it does the same thing as well.
If you don't have Wireshark installed, I would highly recommend you download it. We'll share a link with a bunch of PCAPs that I have saved that I share out with a lot of people. That way you can download them and check it out yourself. What we were looking at was the 802.11 state machine. This is a capture that I've taken a long time ago that just shows pretty simple, like how a device would connect to a Wi-Fi network, right? So as you learn how Wi-Fi communication works, you can open up these packet captures. You learn how to do the packet capture, like we mentioned, using the tools that we listed out. And then you can open these PCAP files within your laptop within Wireshark. We'll also have a link to the profiles. If you want to use a specific profile, you can. And here, the 802.11 state machine, you just have a device making a probe request for a specific SSID. So as you look at the frames, you can see all the information elements here on the left side. You can go through each one of them. So you can see how this device was looking for an SSID called CWAP. And when a SSID is out there broadcasting for CWAP, then you get the probe response from that specific AP. You can see that the transmitter address will change, right? If I go from the probe request, there's the source address, and you can also see it here in these columns that I have enabled, probe response coming from a different device. And then we go into the 802.11 authentication. We know that becomes successful as we look at the information elements. So there's the open system 802.11 authentication, and then it's successful. And then from there, you see the association requests. You also see the acknowledgements for each. I have included those in the frame capture. And then the association response. So that's at least a PCAP for the 802.11 state machine. It's something that we all learn in the very beginning, right, Francois? And now you get to see it from a frame level rather than seeing it from a diagram level. You get to see what that communication looks like. You can tell in the capture I have a signal column which the signal was very strong. And that's because my capture device was in between the client and the AP just sitting on a desk. And so you can start analyzing how these communications look like over the air. And so if you've got a strong signal from the client level, but then a very low signal coming from the AP, then you know that there's such a big discrepancy on the received signal. Sorry, I'm still coughing.
No worries. I think, yeah, one thing that's very important to keep in mind when you do packet analysis is that I don't think you can just go into it and expect to find, a problem right away if you don't really know how it's supposed to work. So I think the best way to do it is to study normal traffic first. So you take a look at some frames when everything is working well, and you try to understand, okay, usually what we look at is how does a client discover an access point. So we look at that. We have two ways of doing this in Wi-Fi. the active discovery, which is what Roel was showing with the probe request, probe response. You have the passive discovery, which is the access point sending the beacon frames. So that's the first step. So you understand, okay, how does that work? How often is this beacon frame supposed to be sent at? What happens if I send a probe request? Which channels are used to send probe requests? And you can study how it works. And once you understand how it works normally, then in the field, you can understand when it's not working normally. You can spot the anomaly, and you can be more efficient at understanding that it's deviating from the norm. And then once you understood, that the client discovered the access point, then the client has to connect to the access point. So it has to go through, the authentication association process that Roel was showing. And if you understand, which frames are supposed to be exchanged when it's, open system authentication versus, WPA2 personal versus WPA3 personal versus, .1x, then you'll be able to identify these frames, this traffic, and you'll be able, once again, to say, okay, this is normal or this is not normal. I should look more into this specific exchange. So I think that's one thing that's important is to first study how it's supposed to be working properly, and that's that's how you can use the little PCAP that Roel is sharing is examples of how it should look when everything is working properly.
All right, why don't we go into showing them some filters, because filters are going to be super handy when you're looking at a lot of frames, right? And you're looking for something specific, you're capturing on the whole channel. And so usually you have a lot of traffic that's coming from multiple devices, multiple APs, not just the simple PCAP that I have where it's two different devices, two different MAC addresses. And filters are a way to cut through the noise and find what you're really trying to look for. I guess we could use the same PCAP file that I was showing, and just imagine that you're looking at thousands of frames and you're trying to find the one MAC address that you're looking for, right? That's usually how I start. Is I'm just trying to filter on everything from a specific MAC address. Now, if you know the MAC address, you can head up to the top here of Wireshark where it says apply a display filter. And usually when I'm doing a capture, I'm not going to filter at the capture level. I just like to capture everything and then I filter within Wireshark. And that just ensures that we're not missing anything, right, Francois? Like, do you usually perform filters after the capture or during the capture?
No, I usually do. I just capture everything and then I filter after, which can take time sometimes if you have a lot of frames.
Yeah,
but that's the way I do it. Yeah.
But usually, if you do that and capture everything all at once, you have the higher likelihood of capturing what you need. Versus when you filter at the capture spot, you may not have captured what you wanted, and then you have to go and ask someone to go recreate the issue because you didn't capture it. And that's why I don't filter at when I'm capturing. I would just filter after the fact.
Also, in the Wi-Fi tools that we use to capture, there's not a lot of options to assign capture filters.
Yeah.
So usually they'll just ask you which channels do you want to capture on, and then they capture everything on that channel, on these channels. So yeah, the filtering will happen after the fact.
Yeah. And so you'll open Wireshark, we'll go to apply display filter, and the very simple one I use is just a WLAN.ADDR for the address. And then you just got to know one of the MAC addresses, right? And so here I can just type in the one I see, just for simplicity's sake of this demo. And once it turns green, you know it's good, right? You have a good filter, because if it's not good, it'll turn red. Like it's not a filter you could actually use. And when you hit enter, I guess this is a bad one because I don't have a lot of frames, but I could maybe, but it's showing me everything that has this MAC address in it, right? The other easy way to create a filter is, let's say you are looking at a specific frame, and let's say the association request frame. If I expand the information element, you could right click on one of these and say, hey, apply this as a filter or prepare as a filter. I can do that, and it actually adds it to the display filter bar, and then it filters out everything in what I'm displaying. Do you have any other tips for? Yeah, I always use the right click because I never can remember the filters that I'm looking for. So I'll always find, if I find that frame, I will right click it, and then you could save filters afterwards as well. Mm-hmm. If there's a common filter you're going to use, you can save it.
Yeah, I love the prepare as a filter because it doesn't apply it, and then you can adjust it. One thing that I do, you can adjust it if you do prepare as a filter.
I can say and this one or this one, and then you can see how that language looks.
The syntax. Yeah, the one that I do is, let's say you also another good best practice when you do your packet capture. Let's say you're studying a specific client. What you want to do is start the packet capture, and then on the client itself, you want to disconnect from Wi-Fi and reconnect, because that will restart the association. You will regenerate the forward handshake. That will recalculate the encryption keys that you might need to decrypt if you want to decrypt it. But also, it will be easier for you to spot your client device, because then you can go back into the packet capture and you can filter for association frames. And then you'll see, which clients associated while you did your packet capture. And then you can, if you don't remember the MAC, or if the device is using random MAC addresses, which can happen nowadays, then it can allow you to find that MAC address. And then when you found that MAC address, you can do a right click, apply as or prepare as filter, and you'll see that in by default in Wireshark, if you select like a transmit address and you do right click, prepare as filter, it will give you the WLAN.TA filter, which is a transmit address. But if you do this, if you apply this filter, it will only show you the frames that were transmitted by your client. So you will only see one end of the traffic. You won't see everything that was received by your client. So usually what I do is I do a right click on the transmit address, apply prepare as filter, and then I adjust the WLAN.TA from WLAN.ADDR. And if you use the ADDR, then you can have both the both ends of the traffic. You can have uplink and downlink traffic coming and going to the client. You see you have WLAN.TA. You can adjust that from TA to ADDR, and then you'll be able to see traffic going and coming from the client. Yeah, there's another thing that you can do in Wireshark, which is pretty useful if you're not using randomized MAC address. So if you're using like a real MAC address, sometimes that could be useful when you do troubleshooting on the client side, to just tell the client, do not use random MAC address, just for the analysis. So you can you can find the frames faster. But you can create aliases in Wireshark. So you can say this MAC address, I'm going to change its name, and it's going to be called, whatever, the name of the device. And so in Wireshark, instead of seeing the MAC address, you can see the name of the device. And then you can do the analysis. I don't know if you can show my screen roll. I have an example here.
There you go.
So here I was doing some analysis on Zebra MC93. So you can see I can change the name of the device. I also changed the name of I changed the name of the access point as well. So you can see the traffic between your client and the access point that way in the source address and in the MAC address. So you can do things like this in Wireshark. It's gonna take place under the preferences. So you have to go and click on Wireshark, about Wireshark, and then you have a folder tab. And in that folder tab, you're gonna find a folder called personal configuration. And if you go there, if I double click on that folder up, I'll bring it on the screen here. It will give me some of my configuration and the file that you want to modify to add these. All of these alias is the ethers file. So you can open it with any text editor, and then you can just put the MAC address space the name, and then it will be taken into consideration by Wireshark.
Awesome.
Yeah.
Well, I do want to take some time to talk about our sponsor. Our sponsor is Meter. They sponsor this episode, and I want to thank them for supporting the show. They're a company that builds better full stack networks while still giving you full control and increased visibility. You can even get your ISP through Meter's dashboard, which is very handy for those who are just trying to find what ISPs are in the area. So you can book a demo by going to meter.com/clear2send. That's meter.com/clear2send to book your demo. All right. So we kind of quickly went through like what tools you can use to do the capture, how to do the capture, some tips on performing those captures, looking at Wireshark. So download Wireshark, and then looking at filters, looking at creating aliases for when you're looking at when you're looking at your capture again. So when you use filters and you use aliases, it really makes it easier for you to start analyzing the PCAP file, because it can get very overwhelming when you open the file, especially if you've been capturing for an extended amount of time, say like 5 minutes or longer. You'll end up with a large file. And the more you use Wireshark to try to look for specific things, I think the better you'll get at analysis. It's one of those skill sets where you're going to have to do this and practice. So look for a specific type of action. Let's say you're trying to just do the 802.11 association of a device. Learn how to capture that. And then you'll learn how to capture other things over time, like maybe ePOL frames. You're trying to do four-way handshakes, trying to do all sorts of different reassociations. We've gone through so many in our troubleshooting that you end up learning along the way how you're going to capture these. And I would write them down as like, here's how I captured this type of frame. Here are the filters I used. And it allows you to then understand what kind of columns you're going to display. And also one tip that I use a lot when I'm capturing frames, and the ones I really want to keep, a lot of times I will just mark the frames, and then I'll export those specific frames. So if I take a look at this file here, and let's say you wanted to capture this is the a pre-shared key SSID, a device going through the association. From here, let's say these frames, these QoS data frames, these are the key frames. If I wanted to just the four-way handshake, if I wanted to export these frames, and let's say I wanted to just only keep the ones that I want, I can mark them, right? So I marked this frame. If I click out of it, you can tell now it's black because I marked it. For me, the shortcut is Command M. And then so I can go in there and say, I'm only interested in these frames. I want to save these individually. You can say File and then export specified packets, and then say I only want to keep the marked packets only. And it tells you how many you've marked. And so that way you could at least keep the ones you want out of the thousands and thousands of frames that you've captured, and then you can just start analyzing those specific ones. You save it off as a very specific PCAP file, so you have your original, and then you have the interesting frames to look at. So that's something I do often when I'm doing a large capture, and then I just find the interesting frames.
Mm-hmm. It's also easier to analyze if you have less frames. So if another good example is, let's say you're troubleshooting one specific client, you're going to capture everything. But if you only need to study that specific client, maybe you can just do a filter on that MAC address and then save into a new PCAP just at those frames. And then you'll be able to filter through those frames faster in Wireshark. Because if you have a lot of frames, every time you apply a filter in Wireshark, it will take a little while. So sometimes I can speed up the analysis.
All right. Do you want to go into, you like using IO graphs, right, Francois? And I think IO graphs within Wireshark is an underutilized feature.
Yes, IO graph it allows you to kind of visualize, different elements of the PCAP. And, I like to use it to analyze roaming behaviors. So, you can, any filter that you create in Wireshark, you can assign it, you can create a graph out of it. So if you wanted to see, all of my frame being exchanged over time, you could see that on the graph. If you wanted to see when is my client starting to look for a new AP, when is my client probing, you can put that on a graph. If you wanted to see when is my client, transitioning to a new AP, reassociating to a new AP, you can put that on a graph. So you can kind of see over time what the client is doing. And sometimes that can help you to understand, some of those roaming behaviors. And then sometimes you can also tie the layer one aspect of things to it. So you can track things like RSSI values. So you can kind of see, when is my RSSI going down, and what happens when my RSSI goes down? What is my client doing? When is my client starting to probe? At which level of signal strength? And you can kind of study all of this with the graphs. So
yeah,
I can show you an example.
That I use, one way I've used the IO graph, because you brought up a good point about, what is the client doing? One time I used the IO graph to troubleshoot an environment where I had to prove to the end user that they picked a too high of a minimum data rate. And I showed them how the client kept rate shifting with the IO graph. It kept picking a much lower data rate when the highest one was like 24. And so I kept showing them, like, look, it kept trying to do 6, 11, 18, and then it got to 24. And so I told them, like, if we drop this to 12, it'll probably have a better experience than trying to retransmit at different data rates. But go ahead. You want to share your screen, Francois?
I think it's very useful if you want to convey something to someone that doesn't really understand the frames. We say a picture is worth 1,000 words. In this case, it could be the case. Well, I have a PCAP here of some roaming test I was doing. So I was capturing. This one was on 2.4, so you can see I captured on 11, 6, and 1. And then I filter for the specific client that I was analyzing. And what I did is I connected the client to the Wi-Fi network, and then I just roamed around with the client, capturing the frames. And so my capturing device was very close to the client, so I can capture also that RSSI value to them. And then in Wireshark, you can click on Statistic IO Graphs, and you can create your own graphs. I actually have it here already open. And this one, maybe we can share this one as well. But this one, you can see how I've included a few different filters, and maybe we can just take a look at it one by one. So the first one that I have here is just the number of frames that are transmitted by the specific client that I'm analyzing. So I'm trying to see, okay, when is the client being active? And I can kind of see I have a few spikes of when the client is actually transmitting frames. And then what I do as well is I try to look at, okay, how much of these frames are retry frames. So I can add another filter to include the retry frames bit. I check if the retry frame bit is to 1, and I can see the proportion of retry frame versus transmitted frames. In this case, the percentage of retry is quite high. If you're listening to this, you'll see that there's plenty of red. We can see that there's plenty of red in my graph. Then I take a look at what I'm receiving from the access point. So how many frames am I receiving? I put that with a different color, green in this case. And then so I have a representation of how much traffic is being generated by this client. In this case, it wasn't much. It was a barcode scanner. And I wasn't running any sort of ping or anything like this on that unit. I was just connected to the application that they were using and just roaming around. So that's why you don't have much traffic. And then what you can do, so far what we're looking at is line graphs. So it's just different lines showing us, the evolution of how many frames we're receiving and how many frames we're sending. What I can also do is I can identify events on the graph. So the one I've just selected is the probe filter. So here I'm looking at, when my client is actually sending probe requests, because I want to know when is my client looking for a better option, when is my client looking for a better AP. And if you're listening to this, I can tell you that there's a lot of probing. Well, I can probably attest as well. But I've done this capture over, I don't know how many. This is seconds, so over maybe 200 seconds, and we have tons of probing all over the place. At the end, it's interesting because it looks like there's some sort of pattern to how the probing is being done, and that's also something else you can identify when you do IO graphs. Is you can identify maybe time patterns. Okay, so interesting. So we can see that the client is probing quite a lot. And then what I want to put on the graph is when is my client associating or reassociating to an AP. So I want to understand when is my client actually roaming. So you can kind of see on the graph, I can also zoom in here. You can see I have a little orange circle here, which means that my client roamed at this point, and then he roamed again maybe 5 seconds later. So I can kind of follow, the evolution of my client and understand, when it roamed, if I go through the process. And when I do roaming analysis, usually what I'm looking at is, how much time do we have between the time that my client starts probing, so starts looking for a new AP, and the time that it actually roams? Because, the less time we have between the two, the better it is. In the perfect scenario, you want, and I'll show you an example later, but in the best case scenario, you want the client to roam as soon as it's looking for a new AP, because that means that your infrastructure is actually providing a good roaming option right away. So usually that's the type of things that I would be looking at if I do some roaming analysis here. And I can also place on the graph the disassociation. So these are the little red circles, because sometimes you'll see, I don't think I have the association here in this graph, but sometimes you can see the client disassociating from the network, and you can spot these as you go. And then the other graph that I have here, and I should maybe I should refresh this so we can have a better view of it. Okay. I usually change the interval to something like 100 milliseconds. Yeah, so you can see the evolution of, I'm going to remove this. You can see the evolution of the receive signal strength. So I can see how the client is seeing the AP, as I'm moving through the environment, and you can kind of see the evolution of that. Here, it's kind of all over the place. I didn't really have a good roaming experience, as you can imagine, in this environment. The client was almost constantly looking for a better option. This is another example.
Some coverage caps.
Yeah, we had coverage caps, not that much, but we didn't have much like overlap between our Wi-Fi cells. We didn't have much secondary signal strength. Mm-hmm. And in that space, because we were kind of like the factory was not like a big logical space. It was like a lot of extensions that got added, and so you had to kind of go around different corners.
Yeah,
that impacted the roaming experience.
Okay.
Yeah, this one is a little different. So I was generating some ping traffic. That's why here there's a lot more traffic generated. And if I zoom in here, this one is a much better roaming experience, because we can see that, I have two squares, so two probes that are sent, and right after I'm roaming. So this is telling me that the client, as soon as it's looking for a new AP, it's finding a new AP option. And then if I look at the signal strength, I can see that signal strength goes down, and as soon as I roam, poof, the signal strength goes back up. And I can kind of follow what's happening here. I can follow my roaming events. It kind of stands out on the RSSI graph here. Same thing here. You can see I probe twice, boom, I roam right away. Same thing here. Probe twice, I roam right away. So this was a much better roaming experience. And
that
the frames captured
802.11r?
Yes.
Okay.
That environment had 802.11r.
Yeah, because the probes and the roams, the roam is right after the probes, so it's quick.
Yes, the association is right after, and you can see in my case here, the client probed maybe 2 or 3 times on the channel before it roamed. So it was pretty efficient, and then the RSSI value just jumped. You can see how it jumped like, I don't know, 10, 15 dBs every time, maybe 20 dBs.
Yeah, I feel like every time you at a hospital chart.
So this is, I would say, but this is a typical, behavior of everything is happening properly. And there's also less red in the graph because we had a much better experience on the Wi-Fi here. Yeah, so you can use the IO graphs in that way to kind of visualize, some experience to confirm, what you felt as a user experience. And then sometimes, like I was mentioning earlier, the IO graph can allow you to see some sort of a pattern over time. If you see something happening at regular time interval, then you can dig into it. Like, oh, what's happening here? And sometimes I can give you some clues.
Awesome. I think that was a very good way of using Wireshark. You can see how powerful Wireshark is. There's a lot of courses on Wireshark. There's some great books on Wireshark, but it's a very powerful tool that you should learn how to use when you're analyzing some PCAPs and wireless frames. I will recommend you guys go to the show notes page for this episode. We will include a lot of PCAPs. That way, if you're not able to do a PCAP of your own, you could at least start analyzing some PCAPs. There's different types of PCAPs will include things from the regular association to roaming, what roaming looks like when you don't have 11R enabled. I even have some MLO for Wi-Fi 7 PCAPs for if you want to see what that looks like. OWE. What else? You've got WPA3 PCAPs, Francois, some neighbor reports, multiple BSSID. So we have a lot of different PCAPs. We've used them to in previous episodes to teach different topics, and Francois uses them for your instruction, the teachings that you do. And so I recommend you guys take a look at the PCAPs, start using Wireshark. Now's a great time to start analyzing wireless frames if you haven't done so before. It's starting to get more complicated. So the sooner you get started with frame analysis, the better off you will be as we get into these more complex Wi-Fi protocols.
Yeah, and then I would say it takes time to do frame analysis, so take your time as well in the process. You will see that all of the language that you'll find in the frame are the same language that you find in the standard, which is not necessarily the language that we're used to. New acronyms maybe. So I would say nowadays you can also use AI to help you if there's something you don't understand. What is this acronym? You can use AI to kind of help you learn all of this instead of going to the standard trying to find the acronym how we used to do back in the days. It might be easier today, but yeah, take your time, and then even if you spend an hour and you learn 2 things, that's already good. Next time around, you can move on to the next stuff, and practice makes perfect here when it comes to packet capture. You just have to spend a little bit of time in it. And the more you do it, usually the more you enjoy it as well. So it's especially when you find those, you really find those root cause problems, and you're able to identify exactly what the problem is. It's really rewarding. All right.
Sorry, I couldn't unmute there.
No problem.
Yeah, I think very well said. Absolutely agree with it being rewarding, especially when you're dealing with a complex issue that just doesn't show up right away. And so the PCAPs are able to help show that to you. You can understand what's happening over a wireless communication between a transceiver and a receiver. But head over to the show notes page, download PCAPs, start looking at them, install Wireshark. Let us know if you have any questions in the Slack channels, and we'll extend that conversation there, because we do enjoy looking at PCAPs. Like Francois said, over time you start enjoying it for whatever reason. I don't know why we start enjoying looking at frame captures. But you can also extend this beyond layer 2. You can start looking at layer 3 frames. Like, it just starts going further if you're dealing with other parts of the network. But I want to thank you guys for tuning in to this episode. I hope you found it useful. And if you have any questions, let us know in the comments. Thank you, guys.
Thank you, guys. See you next time.